Hey guys, Cam back. It's been a while since I've had my dial on the screen, but I thought I might give you a little bit of an update of where we're at with things, and this build's coming along quite nicely. Everything's fitting up quite well at the moment. The machine's working out okay. A couple little blues along the way, but we've got over those. You'll see them in upcoming videos on what we did there and how we got over them. But I thought I might give you a little bit of background on some of the stuff that I've done in the past, just a small snippet of what I've done in the past, and some of the things that I want to progress into and do basically videos of as I progress through. And one of those is a little hit and miss engine, a little Rosebery. I've modelled it up on my 2.5 horsepower Rosebery, my full size one. So I want to go through from creating the drawings, doing the design, doing the modelling, doing the cam, creating the codes onto the CNC machine, and creating the patterns, and from the patterns going through the casting process, and after the casting process going through the machining process. So I think that would be fairly interesting, and there's quite a lot of steps involved in that type of work, and it's probably a little bit more fun to watch than what this is. This is probably a little bit dry, but I'm sort of hoping that when we get through this, we'll move on to some basically model making, some fun stuff, rather than shop tooling. So as I said, I've given a little bit of snippet at the end of the video. Stick around if you want to have a look at what I've done in the past, and as I said, what I'm keen to do in the future. So, all right. I'll get rid of my dial and let you have a look at the video for the next part of this build. Thanks guys.
Right, I'm just going to change the drawing a little bit on this. I'm going to put on the drawing 6.5, but I'm going to take this down 9mm and 9mm, and we'll use a fair bit of that head length. We machine that down to about 15, so we'll bore this out to 15, and then we'll size this to suit that 15, and then if you need to, we can just do a quick little machine off on that face. Little story about Loctite. You might have seen a little while ago one of my videos with Johnny, and the magnificent engines that he's put together. And John worked at Brown & Sharp over in the UK for many years as a toolmaker before emigrating out to Australia, and they had the Brown & Sharp executives out from America touring their facility, and they were fitting some dowel pins or fitting some element where they were using Loctite to retain those elements. And one of the executives came up to John and asked him what was that stuff they were using on those pins, and he said it's Loctite, and the executive hadn't heard of it before. You know, this is going back into the early 60s, and John explained that basically it's like a glue for steel. And there was some looks of consternation on the executives' faces, and they walked off, and there was a message that came out later on in the afternoon that the executives weren't very happy, and that we do not use glue here at Brown & Sharp. It will no longer be used on this facility. So Loctite was banned at Brown & Sharp in the UK. If only they'd known. All right, we'll get this knocked out. So if I get more serious about these cameras, I have to get something positioned elsewhere, because it's hard trying to work around this little mount I've got here. All right, I'll set up and we'll bore that out to 15mm for that reworked head. Right, I'm just doing the finishing pass on this one now. point. Alright. Just have a look at how we look there. So we're aiming for 15. Just touching there. Let's bang on 15. Alright. We'll take that out, we'll set up that socket of the cap screw and we'll start prepping that. Alright, we've got half a millimetre left to go. I love that. We do not use glue at Brown and Shaft. You can just imagine it. Goodness me. I tell you what, those sales guys, you've got to take the hat off to them sometimes going around. They cop knockback after knockback after knockback going through industries. But I'll tell you what, if you sit down and listen to what some of them have got to offer and some of the cutting edge technology that's getting out there, particularly in the mechanical trades, you can save yourself so much time and effort with some of the new products out. And I had a company doing a lot of work for me, a lot of hydraulic power packs they were building for me, a lot of big manifold sets, and the guy had a magnificent poster up in his office, and you walked in and there was this group of British soldiers having an onslaught of Zulu warriors coming at them with spears, and they're there with their old muzzle loaders, and there's the salesman at the back there tapping the captain on the shoulder. I've got something new for you, and he's trying to brush him away. I haven't got time, I haven't got time. And what the guy was holding was a Gatling gun. So sort of sums it up beautifully, I think. Yeah, just what you can get on the market if you listen to some of these sales guys and what they do have to offer. All right, let's knock this off. I won't overcook it this time like I did the last time. Just a tad under the 15 will be fine. What are we at? 0.02 left to go. I reckon I might do that with a file for what this is doing. Alright. A little bit of roughness isn't going to hurt that, where it's going to fit into where it's got to go. About 0.01 left to go. Cut back. Just give it a touch more. Use a finer file. That was a bit nasty, wasn't it? Alright, see what happens when you get too close to the chuck. Jeepers creepers. Alright. Let's bang on 15, that'll do us, I think. That'll do us. Alright, I'm not going to try and part this off. This is a grade 12.6 Umbraco, and these things run up around about 45-46 Rockwell, so very hard indeed. So I'll take this off with a hacksaw, and then we'll turn it around, we'll face it off to length, and I'll put a little bit of a lead in on it as well. I hope this is going to work out. Thought I'd bring you over here just before I press this socket head into this little shaft. One of the things I do is always grind a couple of little grooves just to let the air out while that's being pressed in. The other thing I always do too is I always use a Loctite primer on both surfaces. And I'm just using the high strength retaining compound for this, and I'll show you an example of where I've used this under high load on this broaching press that we're about to use at the moment. There's horrible gooey stuff in it. Just wipe it all the way around in there. Make sure it gets a good coverage with it. Alright. You can feel that airlock, you can see why it's important to. And then I'll just crank this down. Maybe just go in by hand. Give it a bit of oomph. You can see the air popping out of there, so that's why it's important to put a couple of grooves in. I'll get that cleaned up before it starts running all the way through the threads. Alright, that's the finished job. So we'll give that half an hour or so to go off, and I can guarantee you will not move that in any way, shape or form. Alright, so that's it all in place and cleaned up. I'll just take it off and I'll show you this broaching press and what I mean by the strength of this retaining compound. Alright, so this is my broaching press. Well, it's actually converted from a 3-ton press, but I've converted it into a broaching press so that I've got a friction element up here and it holds it up in place. And I just use the 3/4 ratchet drive on a long handle. And all I've done, that's the 3/4 drive socket I've machined down, and that's just Loctited in. That was an easy fit. And I tell you what, I've had some big Tommy bars on this thing to extend this out, and it doesn't even look like breaking loose. So it's taken some fair old loads, that fella. But yeah, converting that into a broaching press makes it so much easier to use. You're not mucking around trying to get packing underneath certain positions to try and use a fixed handle. With the ratchet arrangement, you can set it up wherever you like. Makes life so much easier. Alright, we'll move on to cutting the keyway for the lock washer. Right, so we're just going to cut this keyway for the lock washer. It's just a 5mm keyway, 2mm deep. There's no rocket science in this one. They're fairly rough, not a precision fit. Just to stop the lock washer rotating once we engage the tab onto the nut, to stop the nut backing off once we've set our preloads on our bearings. So we'll do it in 2 bites, so 2 1mm depth shots, and I'm going to go about 13mm long. I'll just try that washer on at that, just see how close it is. Yeah, it's going to be fine. There's a burr on there we've got to take off, but that clamps at the bottom there, which is fine. Alright, well, I'll deburr that, and we'll call that one done. Alright, I think the next element we'll do on this is the worm well that we've got to press onto the end here. Then we can assemble this body up and we can see how that worm shaft is going to engage in this. I'll make up some dummy bearings to sit in those bearing housings in that little gearbox, and we'll just see how much backlash. Hopefully we've got some backlash, just how much backlash we've actually got. Righto, we'll see how this turns out. Hope it's not too wonky. I've decided to make a small change to the fitment of that worm wheel onto that drive shaft. Previously I had an M12 socket header cap screw drilled and tapped in, and then I was going to Scotch key the worm onto this shaft. So it's just drilling and tapping and fitting a couple of grub screws at 180 degrees apart. I'm not a real fan of Scotch keying, but I've decided to actually attach it using 3 M6 socket header cap screws around a PCD. I can see that better on this drawing over here. So I'm going to drill 3 holes, fitment holes for that for those socket header cap screws. What I'm also going to do is drill and tap 3 holes for jacking that off the shaft as well. What I've also done is on that shaft I've decreased, or I've shortened it up a little bit to give me a little bit more meat inside here, because the bore doesn't need to go as far. It gives me a little bit more thread on those jacking screws. Before I start all that machining, one thing I need to do is a survey to find out basically where the centre line of that worm wheel sits in relationship to the worm. So I need to assemble the housing up, and that will be my datum point. I need to get a set dimension from that datum point to the centre line, which will be the centre line from the bearing bores to the outside face of the box. So I'm going to set that up on my surface table and determine where that is, and then I can machine that shaft back to set that position when that worm wheel goes up. So that's the small change that I've decided to make. Not a big change. I'm going to leave that M12 tapped hole that I've already done in there. It's not going to interfere with anything in any way. So I've modified the worm wheel, or the worm gear, and then we're going to be drilling and tapping into the end of that shaft. And as I said, we're going to be shortening that up by 3mm to give us a little bit more meat for those tapping holes. So I'll do that survey first, find out where everything's at on that worm wheel. I'll put it out there. That's a very hard thing to try and hold in a chuck, so I'm going to make up a dummy sleeve that will fit up inside the chuck, that will be split, and then it will clamp, so that we can machine that nice and concentric. When that is all assembled in place, I'm actually going to machine that bore there concentric to the bearing registers on that shaft to make sure that that crank disc is dead concentric. I've also made a mod to that crank disc as well. As you can see, I've actually put that in on a taper to give me a little bit more meat around here for threading. I don't want to break through with these threads for these crank pins. Reason being is that that's then going to expose the oil to be able to come out through that crank disc and the holes that aren't being used. So I put a little bit more meat around there just to give us a little bit more comfort with those threads. Alright, well I'll go out and do that little survey and just find out exactly where that face is sitting in relationship to the centre line of the bores on the housing. And then I'll do some quick sketches and work out exactly what length we're going to make that and how much we're going to bore that back to keep that concentric. Alright guys, so I'll go and do that now, and then we'll get set up in a lathe to start some machining. Righto, so I thought I might just come out and show you what we're doing on the surface table here. So I've got my little 20mm buttons sitting inside the bore, and that's measuring within 0.02 from the top of each one. So I've zeroed my digital height gauge out as the datum. I've machined up a standard. Doesn't matter how long it is, as long as you know what the length is, and that sits down inside the bore and registers on that bearing cup face. And then we just take our digital height gauge over and we just bring it down until it kisses, and that's measuring up at 114.87. So we'll just write that down, 114.87. And my standard was 154.36, so I'll go and lay that out in the CAD and we'll just see how that's panning out. Right, we'll just see how we go here. It's probably going to be easier to show you on the CAD, but basically what I've done is I've put that 20mm diameter in, touching on the bottom of our bore. I've just drawn that in. I've done a measurement from the bearing cup register out at 154.36, and our measurement from the top of that little button that we had to the top of our standard that we machined up was 114.87. So we'll just do a measurement of that from there to there, and a bit hard to see, but that's measuring bang smack on 114.87, exactly what we measured. So basically what I've got on my detail sheets is what we'll keep. So it's yeah, absolutely spot on, so really happy about that. So all that machining where we spent a lot of extra time making sure we had our bores and our depths absolutely spot on has certainly paid off. So, but it's always worthwhile doing that little check just to see where everything's sitting. So at least if I do stick to my details, I know that that worm wheel is going to be dead smack center with the worm shaft. All right, we'll get set up for our next machining operations. All right, I just want to go through what was, I guess you call it a passion of mine for many years. I had a foundry that I was running. We were doing cast iron, bronze and aluminium. We had a big pick furnace. We could cast up to 100 kilo of alley. We could do 50 kilo of bronze or cast iron in the furnaces that we used. And we were primarily a jobbing shop, doing one-offs, but we also did a lot of project work as well. So we ran that for, gosh, 2.5, 3 years, and it certainly takes a toll when you're doing extra work like that. It was 12, 14-hour days on a Saturday and Sunday, either ramming up and prepping for the next weekend or pouring all that weekend, and then coming back and re-pouring again for the things you stuffed up. And it just got bigger than Ben-Hur. We were just getting so much work coming in. It wasn't funny, and it was taking a lot of time out of family. So myself and Ian, who was my mate, we were running that show, decided that that was it. We'd finish off our last contracts, and we closed our foundry up. And I did get a lot of the smaller gear out of that foundry, because I do plan on setting a small foundry up again, which is where I basically started 20-25 years ago in the backyard, just with a small coke furnace. So but when you get into the foundry work, you also get into pattern making. One of the big frustrations with foundry work is getting customer patterns and not having any idea on section thicknesses, materials, flows, drafts. It was just so frustrating. You'd spend most of your time fixing the patterns up so you could actually draw them and actually cast them. So I started doing my own pattern making, and pattern making by hand for me was very laborious and yeah, very time consuming. So I built a 3-axis CNC router, which is what I do all my pattern making with, or what I was doing all my pattern making with. So, and we did a few fun jobs as well, which is these little homers. So I'll just show you a little sample of some of the patterns that we did. And I guess this is inspired by watching Emma's spare room, and she's doing some pattern making for an engine as well. And Emma, you're probably looking at this, seeing some similarities in yours, but this was the split pattern that I did, and I do these out of Jellyton. It's a very stable timber to work with. Very expensive, but it doesn't move. It's got a very fine grain, or really very little grain direction, so it doesn't matter which way you machine it. So that was the pattern that I CNC'd up for that. And obviously you need the core boxes, so Hopefully you can see that on the screen. I can't see the screen, but then you've got the mating core boxes, and once again I did all these in the CNC. Patterns are fairly easy to make. Core boxes are absolutely mongrels. You can see I haven't touched these in a long time. They've got age cracking in them. But I did these in sodium silicate sand and just gassing off with CO2. And later on we progressed into the chemical bonded sands. So that was the body for that little hit and miss engine. And we also did all the little bearing caps that go with that. It's a little bit, oh, there we go, you know, obviously the crank arms with all the little bearing caps on it. I actually did a pattern for the crank. I actually ended up machining these. I did this in SG iron, and SG iron is basically, after you've melted the iron, you do a double dip or a double pour into an empty crucible that's got about 3% ferromagnesium in it. And yeah, you'd only do that once. The the light show that came out after that and the amount of smoke that came out after it was horrendous. So that was my one and only go at doing SG irons for the graphite iron. Yeah, fun and games. Yeah, we did little odd side pulleys for them. Plain flywheel patterns. Once again, these are all just fully CNC machined. So once you've got the drawing, you've modelled it up, you converted that to your STL file and loaded that into your CAM program to generate your tool paths. Very easy to set up and just press the button and let it do its thing and come back, and basically that's a head that's come off that, and that's the, I'll get that up a bit closer, but that's one of the heads. That's the finish you get off it, and once again that's a gelioton, and once again very stable material to work with, very nice material. That's the actual head off there. I've got some core prints so that I can get that connection there showing up. So lots of little tiny cores for everything in here. Little arm support for the rocker. Yeah, cylinder pattern and piston pattern and piston core box. So an awful lot of different patterns that went into a lot of that. That's the base for the whole thing. Yeah, she's all peeling and cracking, so. I did have one very intricate little pattern here. I don't know where that's gone. I should say intricate core box. It was a core box inside a core box, so that was a very tricky little thing to make. So the core box actually drew out of itself. I'll see if I've left it anywhere. I'll be back in a minute. That's the other right hand, left hand wheel patterns. I did some cylinders for some mates that were doing some traction engines, and we've actually done a 3.5 inch barrel single cylinder that we've done all the pattern making for and all the castings for it. So that's my mate Ian. So when I ever get a chance, we'll go over to his house and we'll have a look at that, and we'll have a look at his locos too, because we've done a fair bit of the pattern making and moulding for fiberglass for his diesel locos and the trolling trucks. I found that little pattern, little tiny core boxes, and we draw cores out of the core box. So yeah, once again, all done on the CNC. Makes life so much easier. So that's just a little bit of patterns and core boxes for various other little jobs. I'll show you some of the castings next. Righto, so this is just some of the castings I've had left over from commission jobs and my own little jobs. So these were some Zenith updraft carbies that we did a run of 25. There was all the bodies and all the linkages that went with that. So they were quite intricate, particularly the core box to get that jet boss in there. So I've got some photos of that. One day I'll dig them out and I'll show you how how those core boxes worked on that, but that was quite an intricate core box to do that. One of the things they had to do on this particular job, was a commission job, it was supply the castings. This is one of our trials, supply the castings and the patterns on completion of the project. That was just the cover with the float linkages that could be machined out of that. I've seen all these finally machined up, and they came up, you know, absolutely magnificently. Beautiful looking jobs. That's the piston out of the hit and miss. It's one of the only castings I've got that I can find anyway. We did a couple of castings in cast iron on that body, and a couple of castings in aluminium, and do you think I can find the things? I have no idea where they've gone. They're about somewhere, but I have no idea at this stage. This is for a vacuum pump for a 7 1/4 gauge loco castings. Quite a bit of work in those. There are the end covers for him. We did an awful lot of makers plates in bronze with the linen backing. This chap here, Brent Arman, he manufactured cutter boats and did restorations on cutter boats. Had a bit of a law unto himself that if it was before 1925 he wouldn't touch it. So he built the traditional way. Amazing workshop. Everything was traditional equipment that he used, the traditional equipment that was used back in those early 1900s. And the guy was an insomniac. The quality and speed of the builds was just unbelievable. Unbelievable, just magnificent, magnificent timber boats. So we did an awful lot of makers plates for all sorts of people. Here's a little horizontal wobbler set. I did literally hundreds of these little castings, both horizontal and in vertical as well. Little flywheels for them. My father made or started making and got a fair way down the track before it. He sort of saw no end to it. It was for H-class loco, which was a Victorian, well, the biggest Victorian loco ever built, and the R-classes. So I did a lot of the castings on that particular loco, except for the cylinders. So that's some of the wheel castings that we did. These are some of the trials. We did these out of our Kupler, which was our initial furnace that we used, or melting method that we used for cast iron until we went to the oil burner. So yeah, did a lot of cast iron. And these are some little steam engines that I did. I did dozens and dozens of these for project jobs for schools and for different societies, for projects. Just yeah, lots and lots and lots and lots and lots of bits and pieces for them. So they're all very, very high quality little castings. Very, very, very nice to machine. All done in LG2 gunmetals. So, well, we might show a little bit more of that sort of work. We'll show you my 3D router that I use for pattern making, and we'll show you the project that I want to start after I've completed this slotter, which is a hit and miss engine based on my Rosebery. That particular one I showed you is called the Rosebery model, but it misses a lot of the detail, and the detail is all in the cores, so they're fairly complicated cores to make up. So I've done most of it, and I've got a lot of it modelled up at the moment, and I've actually CNC'd out the main body for that. So that's a little project that I want to get into and share with you guys. All right, well that's a little bit of what I've done in the past, and there's a few more other things in the closet, but they'll come out in time. All right, we'll leave it for now, and as I said, we'll continue on with our lathe slotter.